Hello friends, today we are going to see the universal dividing head which is used in the milling machine to divide the gear plank into number of equal parts. That will cover the introduction to indexing, type of dividing head, construction and working of universal dividing head. So what is indexing? Indexing is a process of dividing the periphery of workpiece into any number of equal parts. So here one blank I have taken, that is nothing but a workpiece, and that workpiece has to be divided into the number of parts. Just by using the protractor, it's very easy to divide so any sketch by using the protractor at a different angles. But on the machine, it is a very difficult task. So for that, we are using the mostly the universal dividing head. This is what I have shown the blank, and now one example you have taken. Suppose you have to cut the 20 number of teeth over that blank. So 360 divided by 20 degree is equal to 18 degree, means the distance or the angle between the two teeth is equal to the 18. So after each teeth, so after when the one tooth is generated, then it rotates the job through a desired angle. So in that case, we are indexing to a 18 degree, and thus the indexing of the workpiece is possible by using the any dividing head. Then so if you want to go to the exact or even in the fraction also, means because it may be 18.5 or other than that also, or even 19.5, any type of angles can be divided by using a dividing head, right, or the indexing head. So indexing is done by using a special attachment which is known as a dividing head. So this is the sketch of the universal dividing head. Okay. A dividing head is a device that is mounted on the attachment on the table of the machine, milling machine. You can see this is a sketch of the dividing head, and we are mounted on the table of the milling machine, and we can hold a component between these two centers. It is used to turn a workpiece in equal angles after an operation is performed, so that same operation is performed at special interval. Means as we are holding the workpiece between these centers, so when you are using the index, you are giving the indexing movement to the index crank, so naturally the workpiece will also rotate. Okay, so after the each tooth you have to rotate to a certain angle. So for that, the dividing head plays a very important role. Application of the dividing head: if you want to generate the fluid on any bar, which is very easily generated by using the dividing head. You can see the number of fluids we can generate there. This is the example or application of the dividing head. So we can divide the blank into a number of equal tooths or equal parts there. Then the next example is the head, that is a bolt. If you are we have taken suppose, and on that we want a head of 4-sided or 6-sided or 8-sided, which is very easily divided by using the dividing head. Then type of dividing head: plain or simple dividing head, universal dividing head, and the optical type of dividing head. But in today's lecture, we'll go more detail on the universal dividing head. So this is the internal structure of a universal dividing head. It consists, if you see in this diagram, it consists of a worm wheel which is mounted on the shaft. This is the worm shaft which carries a worm there, that is a single thread. Then on the other end, we have mounted an index plate, and on the worm shaft also we are mounting the index crank. This is the index crank which is shown in the diagram, and over this index crank we have mounted the index pin. We will see one by one all the details of this. So first is the worm and worm wheel. So in this case, this is how we can see very clearly that so there is a worm wheel, and this worm wheel is mounted over the hollow shaft or a hollow spindle, right? So from the diagram it is very clear. Then there is worm wheel consists of 40 number of teeth, which is a standard for every dividing head. Then it mesh with the worm with a single thread. You can see in this case this worm wheel is meshing with the worm there. So when you are talking about the worm actually, so worm having just on the shaft, we are producing a helical threads, right? You can see in this diagram also. So this is the single worm having a single thread with single start. Okay, in this diagram also you can see, and it's having a helical threads on that shaft, and that's why that shaft is called as a worm shaft. You can see in the worm shaft it carries a worm on one end, means this one we are talking, right? And on the other end here there is a index plate, and you can see the index crank, means on other end we are mounting the index plate and the index crank. Then we'll go more detail in the index plate. You can see on your screen this is actually the index plate, and this index plate is screwed on the sleeve, which is loosely mounted on the worm shaft. Means we are not directly mounting on the worm shaft, but instead of that it is mounted on the sleeve. So, okay, and sleeve is mounted over that worm shaft. So sleeve is nothing but just a hollow part, right? You can see in this diagram also, right? And this index plate now we can, it consists of a number of holes there, or concentric holes over that surface, and which will be at the equidistance. I will show you this. This is how the index plate, and these index plates you can see the number of holes there. So on the, suppose this is a outer hole which having a 52 number of holes there on the plate, then there is a 45 holes there, 39 holes, 33 holes, 27 holes, like that the concentric holes are there in the row, and which can be utilized for the dividing the workpiece into number of I can say the in a number of angles as per the requirement. So for that we need a calculation. Then the index crank. You can see in your diagram there is a index crank there. So this is a index crank. Okay, and this index here also I am showing the index crank, and this index crank is mounted over the worm shaft. This is the actually the index crank, which here also you can see the index crank, and this index crank is mounted over the worm shaft. And this index crank is provided with a readily, the slot is provided there. Then index pin. You can see in this diagram the index pin is mounted over the index crank, right? And this index pin is generally a spring loaded pin, so that we can insert it into the hole of that plate. Now it can, see when you are selecting the holes, you can see in the previous diagram we have shown that the number of concentric holes are there. So out of which the, as per the calculation, we have to select the, whether it may be a 27 row holes there. So in that you have to insert that pin. So for that we need adjustment. So for that reason here the slot is provided, so I can adjust the position of the spring loaded pin so that it can enter into the particular hole circle. So this is the what I'm showing, that slot. And so this is the pin which is a spring loaded, right? That index pin is a spring loaded pin. Then the spindle. Now spindle, you can see in this diagram The spindle is provided with a job carrier and a center at its front end to hold the workpiece. Means here we can hold the workpiece between the centers also, or there is a job carrier so that I can hold the workpiece properly in that job carrier. Both the options are there. Then other one is the sector arm. Now what is the importance of the sector arm? Student, you know that when we are, as there are number of holes on the plate, you can see in this, I will show you on the diagram. This is a index, index plate there, right? And here these are the sector arm. And when you are selecting, and you suppose you are selecting with a 27 hole, right? But the position which you are selecting, it is very difficult and very confusing there. So for that, the sector arm is used. Suppose I'm starting from this position, right? So I'll place that sector arm to that position so that I can eliminate the counting of holes on the index plate. Otherwise, there is a possibilities of mistake. So that purpose only the sector arm is provided. So now the working is very simple now. So first of all, if you want, you have to pull that index pin, and we know that this index pin now is mounted over this index crank. So as we rotate the index pin, so naturally the index crank will try to rotate, and this index crank is mounted over the worm shaft. So worm shaft will also try to rotate, and this worm shaft carries a worm having a single thread, so that's why it will also try to rotate. And this worm wheel, if you see in this diagram, worm wheel and a worm, they are both mesh with each other. So as the worm shaft rotate, so worm wheel will also rotate. Means linear motion of the worm shaft is converted into the rotatory motion of the worm wheel. Then this worm, you can see in this case, whenever we are using the worm, the plate, so in that case so when the crank is rotated, this worm wheel having a 40 number of teeth actually. So when the crank is rotated by 40 ton, 40, the main spindle and the work will rotate through a 1 turn. Means if I give the 40 turns to that crank, index crank, right, continuously, then the work will rotate a 1 turn. Means that is a 360-degree it will cover, right? But for that, how many turns I have to give? I have to give the 40 turns to the index crank, and then only the workpiece will rotate. So here we are just mounting in front of the workpiece, we are mounting, and the work will also try to rotate. So to rotate the crank through the fraction of turn, then index plate is provided, because many times the angle may be a, suppose 18.5 or a 19.5 or any fractional number. So it's very easy to divide that gear blank into n number of equal parts, okay, by using the index plate. So thank you, friend.